Hello, everyone. My name is Chrissy Mitchell, and this is Dara Phillips and Tiffany Kelly. We are the founders of the Stuttgart Elementary School STEAM team here in Germany. We're thrilled to connect with the International Space Station today. As a Department of Defense school, we are honored to serve military-connected families from across the globe. Driven by a deep commitment to STEAM education, we are dedicated to fostering advanced opportunities to inspire students to explore limitless possibilities and pursue a future where they can reach for the stars, both literally and figuratively.
Here at Stuttgart Elementary, STEAM is a huge part of what we do. We believe STEAM teaches our students essential skills like problem solving, teamwork, and creativity, which they'll need for tomorrow's careers. By exploring STEAM, our students aren't just learning facts, they're building the confidence to solve real-world challenges.
From coding and engineering to the arts, our students are preparing to become the innovators of tomorrow. Who knows? One day, some of these bright minds might find themselves aboard the International Space Station, inspiring the next generation of explorers and creators. A heartfelt thank you to NASA and the Expedition 72 team for inspiring our military-connected students to dream big and envision extraordinary futures. From our award-winning STEAM team here at Stuttgart Elementary School to yours, we are grateful for this opportunity. Now here's our first question.
Hi, my name is Claire, and my question is, can animals live on the International Space Station?
Well, hi, Claire, and welcome everybody in Stuttgart to the International Space Station. I'm Sunny, and this is my crewmate, Nick, and we're going to be handling some of your questions today. And Claire, I love your question, of course, because I am an animal lover myself. And so, yes, animals have been to the International Space Station. In our time while we've been up here, not this expedition exactly, but during both of our flights, we have had different animals up here. We've had spiders. Luckily, they've been in their little containers because I really wouldn't want them flying around here. But Egyptian jumping spiders, and we wanted to see how they would adapt to space and see if they would be able to use their method of jumping to find their prey. Another animal while I was up here that we had was Medaka fish, which was very interesting because we actually had to set up an aquarium. Just imagine how hard that would be in space with water, and you might see why in a little later. And then with those fish, which was very interesting, they were all different orientations while initially they were in the aquarium until we turned the light on, and then they all oriented themselves. So obviously they have some innate ability to sense where, how they would be if they were on Earth, and so they figured out that light meant up, I guess. So that was pretty interesting just to see that from the get-go. But those fish were for us to monitor bone density growth. So very interesting that these animals have contributed to our research and our science up here.
Hi, my name is Monroe, and my question is, can you grow plants in space? If you can, do you use soil or hydroponics?
Monroe, I love the question. Plants and animals. We just talked about animals. Let's talk about plants. Yes, we're growing plants up here, and we need to grow plants because if we want to explore deeper into the solar system, if we want to sustain our presence on the moon, if we want to sustain a presence into Mars, we're not going to be able to send all of our supplies. So we're going to have to start growing our own food, and we're trying to figure out that right now here on the International Space Station. So about 10 feet away from me, we're growing lettuce, and we're trying to figure out how does it grow. And yes, we use hydroponics because soil's really hard to control. Gravity on the ground makes all the dirt stay on the ground. Up here, it would just go everywhere. You notice my microphone floats. So it's hard to control. So we're trying to figure out the right techniques and how to simulate the right light to stimulate the plants so that we can grow our own food one day. Great question.
Hi, my name is Fletcher, and my question is, how big is the International Space Station?
So the International Space Station is about the size of a football field, or a football in Europe field, a soccer field, one of the two. It's about the size internally, about a 6-bedroom house. We have sleep stations for 6 of us, and actually 7. Take that back, 7. We have 3 bathrooms, which is pretty nice. We have a gym. And we also have, as I call it, I'm from the north, a mudroom, an airlock, so that we can go in and out in our spacesuits and do spacewalks. So, and as well, you can see all around us, it's a laboratory. So we have a number of different laboratories, one from Europe, one from Japan, the United States, and also the Russians have a laboratory. And let's not forget, outside there's all sorts of science experiments, and so we have a Canadian robotic arm, like a giant crane out there. So all of our international partners participate and live sometimes on the International Space Station periodically. Different people come up here, but we usually have 7 people living here.
Hi, my name is Zosha, and my question is, how does the space station make oxygen?
You know, the space station, we have to have oxygen, right? We have to have oxygen to breathe as a crew, but it also cleans our atmosphere. So when I breathe out carbon dioxide, we have to get rid of the extra carbon dioxide. And so we have a very complicated system where we absorb that carbon dioxide. And we've experimented and continue to experiment trying to replicate what happens on the Earth. How do I take that carbon dioxide and how do I recycle that into oxygen? Because part of that carbon dioxide has oxygen in there. And so we have a lot of sophisticated laboratory equipment that helps us grab that carbon dioxide and produce the oxygen. But we're not quite there yet. So we really depend on the ground to provide us with a resupply because we can't recycle everything. And so it's important every few months we've got to bring up supplies, and part of that is bringing up oxygen.
Hi, my name is Julia, and my question is, does it feel strange to have no gravity in space?
Hey Julia, it's actually super fun and it's really great. It's hard at first to get used to not wanting to be upright, but why do we have to be? We don't have to be. We could be upside down. We could answer questions upside down. It's not like the blood rushes to your head when you're upside down. It doesn't even matter. And once you actually close your eyes to go to sleep, you don't even know what orientation you're in. And so we do have lights on the quote-unquote ceiling just to keep us oriented. And so letters are all written a certain way, but that's really the only reason why. We use every surface, the ceiling, the floor, both sides, and we could just work on them as though they were right in front of you. We have a glove box, as a matter of fact, right next to me here, and I was on my side for a whole day and didn't even realize that I was on my side because it doesn't matter. So it's fun, and you can do things that you probably couldn't do on Earth. I'm not that coordinated, and I feel like I'm a great gymnast up here, for example. So not having gravity is pretty cool.
Hi, my name is Zachary, and my question is, do you have to walk out in space?
We do. We actually work out 2.5 hours a day, every day. Because we spend all this time floating up here, I don't have to use my skeleton to support my weight. I don't have to use my muscles. And because I don't use them when I'm floating, if I don't use it, my body gets rid of it. And so I'd lose my muscles and I'd lose my bone mass. And then when I get back after I land, after the mission, I wouldn't be able to be strong enough to be able to walk. So up here, we try to counteract that. So we lift weights every day. And we also work out our heart and our lungs, our cardiovascular system. We work that out every day, either on a stationary bicycle or on a treadmill. It's super important for our health.
Hi, my name is Adley, and my question is, what do you do to pass the time in space?
Well, Adley, I really have never felt bored up here. There's always something to do. Our schedule, every day is different. We wake up, we look at the computer, and it's like a box of chocolates. What are we going to do today? We might do a science experiment. We might prep our spacesuits to go for a spacewalk. We might work on the toilet. We might work on the computer. We're the ones who are the IT professionals up here, as well as the cleaners, also with the guys on the ground who help us quite a bit. They walk us through a lot of things. But every day is different, and I don't feel like I've ever been bored. When we have some downtime on the weekends or later at night, one thing that we love to do, and we'll probably talk about a little bit, is photography, because we get a chance to look out the window. We have a beautiful window that we could look at our planet and also look out at the universe, and so that's one of the things a lot of people do. I personally, I journal also. I want to capture this experience. And one of the guys on board, Don, he mentioned, I don't really want to do things that I do on the ground while I'm up in space because this is such a unique experience. So we do space things. Like I said, I do some gymnastics up here because I can, and I can't do them down on Earth. So I don't think I've ever been bored, so I haven't had to pass the time. Really, the time goes.
Hi, my name is Ruby, and my question is, how do you safely exit the space station without letting all the air escape for others still inside?
Great question, and it just so happens that we're next to something that lets us do that. So right behind me is the Japanese laboratory's airlock, and so I can put an experiment in here, so I can open up the door and there's air inside, and then I can put the experiment in, close the door, and then we can take all the air and pump it back into the space station, so it's a vacuum inside of the airlock. Once that's done, there's another door on the outside that we can open up, and the robotic arm will reach in and grab that experiment and then take it outside so it can be performed. And so that's an airlock. We also have another one in a different part of the station that lets us get into spacesuits and go outside.
Hi, my name is Adam, and my question is, since there's no gravity or sense of direction in space, is it possible to get dizzy?
Well, yes and no. You don't have gravity that's creating that force, but you do have centrifugal force. So if I spin Nick, which I can do, just like that, you might get a little bit dizzy on your head. And so you might feel a little bit funny. And honestly, coming up to space for the first time, when you just get to microgravity, it is a little bit disorienting because, think about it, on Earth, your whole body is used to gravity. Your inner ear, which helps you balance, is used to gravity, and all of a sudden it doesn't know what to do. So your brain and your inner ear are going, what is happening? And so you do get a little bit dizzy when you first get here. But when you are here for a little while, just doing some gymnastic maneuvers, it's not a big deal. But you can spin up. You essentially are a centrifuge if you spin up too fast, like I was just doing to Nick, maybe a little bit more, and he would have really got dizzy. But we can get dizzy up here, but honestly, we don't actually move that fast all the time. So you're over it by the first day you're here.
Hi, my name is Marshall, and my question is, do you have a science lab in space?
Marshall, oh, do we have a lab? We've got lots of labs up here. So we're in the Japanese Space Agency's laboratory. There's the European Space Agency's laboratory, the U.S. laboratory, and then we have Russian laboratories. And in each of these, we've got all the things you would think about being in a laboratory. We've got microscopes, we've got glove boxes, we've got workbenches and lots of tools. And all of these things are here because we're trying to do science experiments. And the thing that connects all of these science experiments is they're asking what happens when we take gravity away and then we look at everything else that's left, because gravity is such a strong force on the ground. It kind of masks and hides a lot of important details that help us understand better about how things work, how our bodies work, how the universe works around us. Yes, if you want to do research, this is an amazing place to be.
Hi, my name is Addie, and my question is, how long does it take for a satellite to come back down to Earth?
That's a really interesting question, and I hate to say it depends, but it sort of depends. And I'm just going to talk from a reference that I know. Nick probably knows a little bit more because he's in the Space Force. I'm a Navy guy, but what I know is coming back to Earth in a capsule or a space shuttle, and when we decide where we're going to land, where we're going to land and when we're going to land, we sort of back up the time from there to figure out how to get that spacecraft back home. So it all starts on when is a good day to land and where you're going to land. And then we back it up by when we're going to just slow down just a little bit. We stay in orbit by traveling about 17,500 miles an hour. So if we slow down just by 300 miles an hour, we're going to start coming back into Earth's gravity. Gravity's going to pull us back to Earth. So that's the math to figure out how much you need to slow down to land in that one specific spot. And so sometimes it takes a little while to make sure we're over the right orbit, over the right place of the Earth. So that might take a day to make sure that we're in the right orientation to do that slowdown. Or the space station might luckily be right over that place at the right time, and then we could just undock and then start the slowdown. But once you start the slowdown, it's a matter of about an hour, 45 minutes to an hour, until you're going to come down and land on the planet from our orbital altitude.
Hi, my name is Luca, and my question is it hard to become an astronaut?
You know, it is hard. It takes a lot of hard work. I'm not going to hide that fact. But it also takes a long time and a lot of commitment. And you don't become an astronaut just because of yourself. I think the unique thing about everyone that comes to the astronaut office is that we come from teams of people, and those teams have made us who we are. And so it's collectively. So you're starting your education now, and you're going to continue that on. And as you grow older, you're going to find yourself in different types of teams. Not necessarily all sports teams. There'll be different types of teams. And those teams are going to help you become better. And you're going to help the people in the team become better. And slowly over time, over the course of 10 years or 20, with a lot of hard work, you finally put in your application to the astronaut program, and then you've got a shot. So it is hard, but it's definitely doable.
Hi, my name is Alex, and my question is, what is the most important piece of equipment on the space station and why?
That's a tricky question. There's a lot of important stuff up here. You know, we're obviously living up here, so this is a little life, so we have to stay alive. And I think one of the questions earlier we talked about was oxygen. So I would also bring up water. Water is really huge because we do a lot of things with water. Water is life, right? So we also split water, H2O, to make oxygen. But I think the most important thing on the space station is our rescue vehicle, or our lifeboat that is always attached to the space station. It is just, I'm a Navy guy, remember, this is just like a boat, and so if you go out on a boat, you want to make sure that you have, you know, a life preserver or a lifeboat. And we always have a spacecraft docked to the space station for us, just in case there's any emergency, like a micrometeorite hits the space station. Some of the things we worry about is just like what you worry about probably at school: fire drills, you know, we practice that, or a depressurization. So if we have experience any of that, all crew members have a place to go to. So I think our lifeboat is probably the most important thing on the space station.
What an amazing experience. On behalf of our Stuttgart Garrison community, thank you to NASA and the International Space Station crew for this unique opportunity. Today, you've inspired our students to reach new heights and dream big.
And to our students, remember that curiosity and the passion that you've shown today are the key to an exciting future. Whether you're solving problems in the classroom or exploring beyond, you are the future innovators and explorers.